let's talk about something wild. What if you could travel through space, not with rockets pushing you from behind, but with something pulling you from the front? Today, we're diving into a fascinating, kind of out there proposal from 2002 called Quantum Electromagnetic Laser Propulsion. Right off the bat, the guys behind this make a claim that is, well, it's pretty audacious. They basically say that everything we think about for space travel, rockets, solar sails, you name it, is a dead end. For them, the only realistic way to get to the stars is through something they call macroscopic quantum tunneling, a concept that, if true, would change everything. So what's the big difference here? Well, for centuries, getting around has been all about action-reaction. You push stuff out the back, you move forward. Simple. But this UNITEL idea, it flips that completely on its head. Imagine being pulled forward by an invisible electromagnetic field that your own ship creates. It's a total paradigm shift from pushing to pulling. So who came up with this stuff? It was a couple of inventors, Larry Maurer and Michael Miller. After working on it for about 2 decades, they published this proposal back in 2002. It was basically a big promotional piece for their company, UNITEL, and their wild solution for getting between the stars. And what they proposed was, honestly, revolutionary. Get this, a spaceship with 0 moving parts. No engines to break down, no giant heavy fuel tanks, and absolutely no propellant, which means you can't run out of gas halfway to Alpha Centauri. The whole thing, they claimed, would be purely electric. All right, so what does this thing, this vessel, actually look like? Let's break down the craft itself. They call it the teardrop ship, and it's the foundation for this whole new kind of physics. You see that teardrop shape? That's not just for looks. The authors say this specific shape, which they call the general vector potential, is the absolute perfect form for interacting with electromagnetic fields. They even argue it's the fundamental shape of particles, like electrons and photons. So the ship's actual geometry is a part of its engine. And the hull, which they call a smartskin, is just as wild. It's a complex sandwich of materials. You've got this outer layer made of a niobium, tin, titanium, and diamond composite. Underneath that, there's carbon fiber and a lightweight aluminum frame filled with helium gas. And the total weight, get this, just 300 to 400 pounds. That's insanely light. Okay, to give you an idea of the kind of power we're talking about here, the authors point to a real-world experiment. At Berkeley Labs, researchers used a similar niobium-tin material to create a magnetic field of 14.7 Tesla. To put that in perspective, that is 300,000 times stronger than the entire planet Earth's magnetic field. That's the kind of insane energy this smartskin was designed to harness. Now for the engine itself, and I love the analogy they use for it. They call their propulsion system the laser pull drive, and they describe it as a front-wheel drive system for space. I mean, how great is this quote? It just perfectly captures the idea. The ship isn't being pushed, it's being pulled, sucked forward through a tunnel it creates itself. It's such a simple, powerful way to visualize what they're proposing. Okay, so how does this magic work? In theory, it's a 4-step deal. First, a magnetron, kind of like the one in your microwave, shoots out radio waves. Second, a special 3-part laser lens turns those waves into a spiraling plasma beam. Third, that beam creates what they call a magnetic flux tube, basically an invisible tunnel right in front of the ship. And finally, the ship's hull, which is electrically charged, gets pulled forward into that tunnel. Simple, right? Here's another great comparison they make, a maglev train. A maglev needs a physical, super expensive track to float on. But this UNITEL craft, it creates its own track, that magnetic flux tube, as it goes. It's a totally self-sufficient, trackless train for the cosmos. Okay, now we get to a number that is just mind-bending. The authors claim this system creates a pull that is 39 orders of magnitude stronger than Earth's gravity. We're talking about a 1 with 39 zeros after it. It's a number so astronomically large, it's stronger than the force that holds the nucleus of an atom together. It's a lot. But just moving around in space, that wasn't the real prize. The ultimate goal here, the whole point of the UNITEL project, was to achieve faster-than-light travel by, as they put it, tunneling through space-time. And the key to this is macroscopic quantum tunneling, or MQT. Now, on a tiny subatomic level, quantum tunneling is a real, super weird thing. A particle can just kind of pop through a solid wall it shouldn't be able to cross. Well, they proposed scaling that idea up, way up, treating the entire spaceship like one giant quantum particle that could tunnel through the biggest barrier of all, space-time itself. So what happens when you do this? Time gets weird, really weird. By popping into what they call hyperspace, they calculated that for every 1 hour that passed for you on the ship, 3.6 years would pass back here in real space. A journey that's 250 light years away, you could do that in about 100 hours of your time, just over 4 days. Think about it. And to back this all up, they pull out a powerful idea they attribute to Albert Einstein himself, that to travel these unbelievable distances, you don't speed through space. You have to actually change the structure of space. And that's exactly what they claim their ship does. And this is a really important detail. They're not trying to break the speed of light. That's a big no-no in physics. They're trying to find a loophole. The ship takes a shortcut through this other dimension, this hyperspace, and arrives at its destination faster than light could have gotten there in our reality without ever breaking the cosmic speed limit here. So, with all this incredible ambition, what happened? Where did it all go? What's the legacy of this amazing and, let's face it, pretty bizarre vision? And this wasn't just some fantasy scribbled on a napkin. They formed a company back in '82. They actually got US and Japanese patents for the core concepts in the late '80s and early '90s. This document we're talking about came out in 2002 to try and get funding. But sadly, it seems the project hit a wall after co-inventor Larry Maurer passed away in 2011. Now, to try and connect this grand theory to something, tangible, they pointed to the controversial Biefeld-Brown effect. This is the idea that high voltage on a certain shape of capacitor can create a tiny bit of thrust with no propellant. They looked at those simple foil lifter devices you can see online as a small-scale proof of their much, much grander idea. You gotta hand it to them. They knew how wild this all sounded. This final quote really sums up their whole vibe. It's defiant, it's self-aware. They knew they were way out on a limb, and they were proud of it. And that's where we're left, with a big question. Was this a glimpse of truly groundbreaking science? Or was it just really, really cool, elaborate science fiction? For things like this, whether it's Da Vinci's helicopter or the first rockets, the line between imagination and reality, well, it's usually only clear when you look back.